Today we're talking about WAN quality reports and how to view them through InControl2. WAN quality reports are done at the device level. We're going to take a closer look using this Balance 1350. Go to the Reports tab and select WAN Quality Reports. WAN quality reports track every active WAN on any given router, whether it's an Ethernet connection or an LTE connection. It tracks quality metrics for those WANs and rolls all that information up to InControl2. So for this particular router, it only has one Ethernet WAN, and this is on a cable modem connection. As you see, we selected the date and it's chosen WAN 1 by default. It's going to show you 30 minutes of time initially. In that time, I've got about 30 to 40 milliseconds of latency, and it looks pretty stable. We can widen the view out, click on All, and now you can see something happen right around 5 a.m. The latency wasn't terrible before, but it's certainly higher in the 40 to 60 millisecond range sometime right around 5 a.m. Then things kind of smooth out and level off right around 30 milliseconds. I also see we get a couple big spikes, around 30 to 50 millisecond latency, which is really no big deal. However, this is a great place to start troubleshooting when we hear issues of voice quality or slow bandwidth speeds. Just begin by drilling down into the individual WAN connections for that router and take a closer look. Maybe there are large latency spikes and lots of different activity tracked, so these are good places to dig for data or clues to figure out what might be causing your issue. And if you were seeing low quality performance on particular WANs, that's where you can start looking at Speed Fusion as a way to help work around some of those issues. Moving back to our Ethernet WAN reports, there's not a lot of data to look at necessarily. It's definitely very useful, but pretty simple and straightforward. If we have a cellular-based connection, we can start to see a lot more information show up. For this particular unit, I'm going to go to a day that I know this was moving around. So here we can see a much more complicated graph. There's a lot more data on the graph showing up here, such as the carrier, the LTE band that is being used, and then you can see the different signal metrics like RSRQ and SINR. You can also download this information. Just click on this download and it downloads as a CSV file. It's coming up to almost a meg of data, so there's lots of data points. We'll convert this to a Google Sheet so you can read it a little easier. There's tons of data that we're grabbing with respect to the cellular connection quality over time, so you're getting all kinds of data points. You get the latency, all the relevant signal metrics, the location, and timestamp. This raw data can be turned into some other sort of report or imported into some other system if needed. Again, we can switch to different WANs. I'm going to go to a different carrier. Cellular 3 is a Verizon connection. Like with the previous connection, you've got all this data mapped out over time. You can see different events at the top. WAN down, WAN up. So if you lose a connection, it goes offline and online. That's when the router is booting up or shutting down. You've got lots of nice flags here to show you different events. Now looking at a graph of cellular signal data can get boring fast. So what I think is the more useful perspective is the map view. Like I said, on this day, the unit was moving in for a considerable amount of time. You can see that all those readings kind of smooth out over the course of that trip, and so in general, this is pretty good connectivity. If we click on any one of these dots, you can see that it's made up of individual records. Click on any one of them to see the details. It will show you specific readings. As you can see, there's a couple in there that aren't that great, but in total, they average out pretty good. Now, if we want to zoom in, you can see those individual dots in a more granular fashion. You can start to zero on where your coverage issues might be, or your signal quality issues might exist. We can see this is where the quality starts to degrade. So get some clues from the larger view, but then as you drill down, you can really start to break out where those trouble spots might be. That's Verizon. Let's switch carriers again and just see what the map view looks like for a couple other carriers. This one is T-Mobile. Once again, there's mostly good coverage on this route, but there's a couple spots that look a little more glaring than Verizon's did. All in all, pretty isolated stuff. Now we can use these tools up here to start drilling in and looking for more specific issues or different metrics. I'll take away the strength and the quality so we can look at just the latency. If we look at latency less than 500 milliseconds, that's good performance in general. If we look at over 500 milliseconds, there's where we can see the user is actually experiencing an impact of their traffic. In all of these areas, the latency metric recorded higher than 500 millisecond. So that's where you're going to start to see the performance really degrade for you. Now you can change that threshold if you want. If 500 isn't the right perspective, let's turn it up to over 1,000 milliseconds. These are getting to be pretty terrible in terms of user experience. You can start to really zero in on particular areas where you're getting a bad user experience. And so in this case, you can see the strength is very poor, the quality is very poor, and the latency is very poor. For strength to begin with, antennas are about the only thing you can do to really improve that. So that's not necessarily a carrier fault or carrier issue. It might just mean you don't have enough antenna to really make the connection work well in that location. Now in this location, you can see signal strength is very good, the quality is very good, but the latency is really high. So this is more of a carrier site issue. It doesn't look like there's much you do to fix this issue, but again, I'm putting in a couple data points and clicking on a few circles, and I know a lot about the user experience and what the sources of those problems might be. With only about 5 to 10 minutes of research here, there's all kinds of powerful things you can do with this data at your fingertips. Now let's go back and filter by signal strength. Like I mentioned earlier, there's things that you can influence and there's things that are kind of out of your control. Signal strength to a point, you have some control over that. Again, you can find better antennas. You can reduce the cabling in between your router and the antenna. You can do things to influence the signal strength. You can't put new towers up, but you can optimize the signal within whatever towers they have available. Here you can see there's several areas where the signal strength has hit our threshold of very poor. So again, this would be a good way to show that it might be worth spending some time and money on getting a better antenna set up with the device. Again, you've got lots of data points that you can manipulate here to get the exact perspective that you're looking to troubleshoot. That's all there is to WAN quality reports. We hope you've enjoyed this video. If you're looking for similar videos, please subscribe to our channel.